Hello, everybody. Oh, this is on. It did turn on very kind of inconspicuously there. And it is 1 minute to start. I know my clock reads 1 minute early, but I'm going to start anyhow, at least say hello. My name is Leonard Lobel, and I'm really happy to be here. Ik spreek een beetje Nederlands, niet genoeg om een sessie te geven, dus we doen het in Engels. Hopefully that's the language that most of you are reading your documentation in, I think, anyway. My little bad joke to get things started. Welcome, and this session is all about different ways we as developers can secure our database stored in SQL Server using features new in SQL Server 2016. That's what the session is about, and it's normally a 75-minute session. So I have to be a little creative with how to make it all fit, and one of the ways I'm going to do that is I'm going to abandon the slides for 2 out of the 3 topics and maybe flash through them for review after, but they're really there for your review, and we're going to just dive in with demos, right? Now it is exactly 1:15. My name is Lenny Lobel. I'm from New York City. I'm really just a geek who loves to write code. Just about the only thing I enjoy more than writing code is writing and speaking about it. To wit, I have written several books on SQL, and I've produced several Pluralsight courses as well. And my contact info is here on this slide if you would like to reach out. I would love to hear from you. So with that, yeah, I believe you get all of the content. It's provided, but I always put my stuff up on my own OneDrive at this bit.ly link, and it's all lowercase, TechDays 2017 _ SQL Security. So again, this is about how to secure our applications running on SQL Server. So this is a dev focus session. This is not a DBA session. And it's these 3 topics that we're going to look at. And like I said, for the first 2, I will pretty much abandon the slides. Then we'll see how the time is going, how we balance slides and demo for Always Encrypted. So let's just jump in with dynamic data masking. And this is a way that we can conceal sensitive data from people that shouldn't see it, not by encrypting it, not by modifying it in any way, but simply by masking it on the fly, hiding it from the query results presented to these users that shouldn't see the real data. So we're not modifying any data. To be clear, this is not encryption. I'm going to create a database called MyDB, and I'm going to create my membership table here. And you'll notice the new syntax, masked with function. I've got a couple of them. And there are actually 4 available functions. If I lean on this, it's going to come crashing down, isn't it? There are 4 of these new so-called masking functions. I'm showing only 3 of them. But really, this one is silly, and I'll show you what I mean. So there's the partial function, and that lets you partially expose what's underneath. Here I'm saying you can see the first 2 characters, you can see the last 2 characters, but everything in between is going to get replaced by 3 dots in your query results. The default function is really poorly named. It really means full, and it is the only one of these functions that works across all data types, not just numbers and strings, but even the more specialized types, as you'll see. And this is the silly one because it's just really a shorthand. There's nothing you can do with the email function that you can't do with the partial function, again, as you'll see. It just makes it look like an email address, but you can achieve the same thing using partial. I already did go ahead and create that table, didn't I? Yeah, I had. So, before you're working with this table, you should be aware that there's this new view, sysmasked columns, and if I join it on systables to look at a table name, I can discover very easily using this query all of the masked columns in my database, all the tables and the columns, and the masking function being used to mask the data in those columns. Let's populate the table with some data, including some of that sensitive data that we're masking, and let's query from the table. And when we look at the output, this may or may not be what some of you were expecting. I think perhaps some of you might have been expecting to see this data being masked. So masking all has to do with permissions. It's a very binary thing. You'll see when we move to RowLevel Security, it's more there are lots of more gray areas. But with dynamic data masking, or DDM, you either have the unmasked permission or you don't. And I have the unmasked permission. So let's look a little closer and see what I mean by that. I'll create this view. It's kind of a handy view that joins together a bunch of these security-related tables so that I can view all of the users and the login name that they're mapped to, the type of login, the permissions that they have, the objects that they have permissions on. And for now, I'm only interested in users DBO, which of course exists, and test user, which we'll create in a moment. Let's query from show users. There's only one user in here, DBO. But if you look at this user, it is mapped to the login name Lenny10p/Lenny. And down there in the lower right, I hope you can all see it, and I'll magnify it in case you can't. You can see that I'm on a connection here by that very same Windows authentication login. And that means that I'm mapped to the database user, DBO. And in case you didn't already know, DBO is that special magic user that has all permissions, right? It looks like they can just connect to the database, but really they can do anything and everything, including the unmasked permission. And that's why the data appears unmasked. And that's also why you should really understand that masking doesn't modify data. You can see it coming clearly. But now let's go ahead and create that test user. Test user, unlike DBO, and any user, unlike DBO, you have to explicitly grant permissions. So I won't even be able to select from this table at all if I don't at least grant the select permission on the membership table to the test user. So now when I query from the view, I can see that the test user can connect to the database and also has select permissions on the membership table. Great. So now we're using execute as to impersonate that user. Now when I query from the table, of course, the data appears masked just as we instructed. And it's pretty smart about like completely concealing names that are actually fewer than 4 characters, like Dan and Jane, I think there was in there, you know, with only 4 characters. Because if you're only showing 2 from the front and 2 from the end, if there's 4 or fewer, it's because it's going to completely conceal it. You can see that the default function, which I told you should really be called full, will just take any string and replace it with lowercase x's. But the email function just exposes the first character and from the beginning, exposed no characters from the end, and just placed this mask inside, which I could have done myself with a partial function. Now, eventually, of course, this is just a demo, but in reality, you're going to have users that are going to be assigned into roles. So this is great for a bunch of developers in the developer role that you do not grant the unmasked permission to. Makes it really easy to make. You know, if you're like me, I struggle very hard to get my hands on data, production data that I can't be, that I normally don't have access to because of phone numbers, social security numbers, private information. And masking is a real easy way to cope with that problem. So I'm just doing this at the user level, but I could go to I could go either to a user or an entire role or group of users and grant the unmasked permission. And now, when you look at our view, you can see that this test user also has that necessary unmasked permission, which DBO has implicitly. And now when I impersonate that user, the data is not masked, of course. Reverting back to DBO, once again, deciding at this point we no longer want to permit that user. We can revoke the unmasked permission, and that user no longer has permission to view the data unmasked and can only view the data masked. And to round out the demo, this is one I'm kind of graduating here. This is the simpler one. RLS gets a little more involved, but it really is this binary. It's like, yeah, on or off. You either have it or you don't. So I demonstrated the default function, and I also demonstrated the partial and email functions, but I didn't demonstrate the 4th one, which is the random function. So let's look at this crazy table here that I have with all these columns in it. Let me create it first. Whoa, look at all those columns, all right? What I have in here is not just strings and numbers, but dates and times, and XML types, CLR types, spatial types, hierarchical data types, XML, and you can see that the default function, which again, think of that as full, it fully hides the data, the underlying data in that column, works with all of that variety of types. The partial and email functions, which again are very silly because email is just silly and stupid. I mean, this is the equivalent to the email function. What would be nice is if we could create our own functions. What if I wanted an email function that exposed the first character after the @ sign? Right? That would be nice, but you can't do it. So email is really think of there as being 3 functions that you can work with dynamic data masking. The other one that I didn't show yet being random. And this one only works on numeric types. Interestingly enough, of course, the bit data type is treated as a numeric type in SQL, so you can randomly generate Booleans as well. So sure, I could use the default function to hide numeric columns, but they would all get yes, sir. application will receive think of SSMS right now as your application, and think of the connection between your application and SQL Server as this connection that I have here now. It's all in the connection string. It's all in the permissions granted to the user mapped to the login. Because of course, when you connect to SQL, when you connect to a database, first you connect to the server instance via a login, and then in this case it's Windows authentication, but it doesn't need to be. So it's all in the connection string, and it's really just on or off. And here, bit will work as long as you supply a range of 0 through 1. But you can use a range of 1 through 12 if you wanted it to somehow simulate the month of a month column. Perhaps. It even works with decimal types and floating types as well. So if I create that crazy table and I insert a few rows of data into it, and we look at it now, unmasked, I see strings and I see numbers, I see dates and times. These are all based on the default values for the table when I inserted data. So I've got some XML with the word hello in it. I've got some binary data. I've got a hierarchy ID data. I have spatial data. Geography and geometry is spatial data. More strings, more numbers. And now, when I have to at least grant the select permission on this table to test user, but of course I won't also grant unmask. And so when I impersonate that user, the data will be masked. And I'll run the query twice to better demonstrate the effects of the random function. But you can see, as we saw in the earlier demo, in the case of strings, you get 4 lowercase x's when you use the default function for full masking. In the case of numerics, you're going to get zeros. Get dates and times, you're going to get January 1st, 1900, midnight. XML, it just gets replaced with this one element, masked. All my spatial types, zeroed out. Hierarchy IDs, spatial, geography, and geometry types. Here's partial. Here's partial being used to emulate email. And here's the random result, which if I scroll both results all the way over to the right, you can see that in each case we get random data replacing the original data down on disk. And that's really all there is to DDM. Can it be that easy? Yes, it can, and it is. And there's not much more or less that you can do with it beyond that. Now, when we move on to row-level security, things get a little more interesting. Having a look at the time, I think I can at least brush through a quick review of these slides. So we talked about the 4 functions, and we understand that data in the database does not get changed. This is the new syntax that you use to apply masking to individual columns, and it's really just as easy to alter an existing table and add masking to a column using this alter table syntax. We covered all of the 4 functions and how only the default function works with all data types and how the other functions behave as well. We looked at this sysmask columns to see how we can discover what tables and columns are using DDM. So to be clear about permissions again, you don't really actually need any special permission to create a table with masked columns. This is a little bizarre. It's a write-only potential. I might be able to write data that I will not be able to read back. So I don't need any permission to create a table with masked columns, but if I don't have the unmasked permission after I write data into that table, I won't be able to read it back. For those of you who are concerned with how this might work on columns that you join on, it's not a problem. It's resolved only at the time that the results are displayed to are emitted to the user, much later at a point in time than the query is executed. So if you want to alter an existing mask or add or replace or remove a mask, then you do need this alter any mask permission. But of course, again, this is the big one. The unmasked permission is the big one. That's the one you want to make sure not to grant to users who shouldn't see sensitive data. This write-only behavior, again, you can update data in a masked column that you can then not read back the value that you updated. So that's DDM. It's pretty easy. It's pretty straightforward. But now, yes, sir. Correct. That's correct. And that should make a little switch go off, say that how secure is that? Because I might now be able, a hacker could now perhaps infer what some of those values are. This is not ironclad security. This is masking. Nothing more, nothing less. What you see is what you get, and with the RLS, you actually get a bit more. With row-level security, things get much more interesting. Now, to be clear, I'm saying row, R-O-W, level security, not role-level security. Go ahead and use my same database. And we're going to break this down into 2 demos, all right? We're going to have 2 scenarios. So row-level security, the requirement isn't new, but we've always, until now, had to roll our own solution further up the stack at the application level, at the data access layer. And now SQL Server embeds this functionality right into the database engine. The idea that I should only be able to see rows that belong to me and not rows that belong to you, and vice versa, and that's in terms of at least reading, and in terms of writing, we might have similar rules as well. Or maybe I can read everybody's, but I can only write my own, and those sorts of things. So we're going to break this up into 2 parts because it's a little more involved than dynamic data masking. And in this first example, we're going to have a read-only scenario. So I'm going to create the sales table and load it up with 6 rows of data. And there they are. And now I'll create our users for our scenario. We've got 1 manager and 2 sales users. And for demonstration purposes, I don't even need to associate them with a login. So these are database users. Understanding that you don't always have database users, and that'll be the next demo. But in this demo, we have individual database users. And I also said in this first demo, we're going to keep things simple by making it read-only, not to the manager. The manager can insert, update, and delete, but our sales user 1 and sales user 2, we're just going to grant select permissions. So the fact that they won't be able to update data in any way has nothing to do with RLS, row-level security. It's traditional SQL Server permissions. This next step is not absolutely required, but it's always a good practice to use to create a schema to isolate your security-related objects. By the way, if I can digress, it's always a good idea to not use the DBO schema. Even if you can't imagine a case where you might need more than 1 schema name, it's still good to create 1 schema name other than DBO and use that. It makes your databases more portable. There's a host of benefits to that. Okay. Putting that sermon aside, at least in this demo, we're going to follow that best practice. And I've got this SEC schema, which is, again, is not absolutely necessary, but that's where I'm going to create this function called FN security predicate. And it can really be called anything. So the way that you implement RLS is by writing a predicate function. This is a table-valued function. Folks are not familiar with table-valued functions, and it's okay. Go ahead, raise your hand. It's okay. That's fine. Folks that are familiar with table-valued functions that are not familiar with the difference between multi-statement table-valued functions and inline table-valued functions, more hands should go up. Okay, good. So to be clear, this is an inline table-valued function. If you're not familiar with a table-valued function at all, it's simply a function that you can call like any other. You can pass it parameters and get back a result. The fact that you get back a table as a result, that's what makes it a table-valued parameter. That's fine and good. So you call it like a function. An inline table-valued function is a table-valued function that has only a single select statement in it. As you can see, after the return statement, it has a select, and that's it. A multi-statement table-valued function, as the name implies, has a begin and an end, in between which you can have multiple statements, hence multi-statement, and you can do anything and everything, including the laundry. You can make web service calls. You can read and write files. And these are not supported for row-level security. Why? Because SQL Server is going to call this function for every row in the table. And your job is to return a Boolean, true or false. A Boolean, true or false, then why am I not returning a bit? Why am I returning a table? Well, logically, you're returning a Boolean. But technically, you have to return a table by the nature of the way SQL Server behind the scenes implements a cross-apply, where it runs this query against, and it essentially joins on this table-valued function. So the job of the table-valued function is to return a scalar result set. That means a single column with a single row, with the value 1 in it to mean true. And if you want to convey false, you actually don't return anything. It's not like you return a scalar 0. You just don't return a result set at all. And by nature of the cross join that occurs behind the scenes, which is similar to an inner join, where it runs this function for each row, that's how you convey truthiness, or true or false. And all I'm doing here is I'm creating a function that accepts a username parameter. Presumably, we will map that column to that parameter to the username column. So SQL Server will feed into our function that column value for every row in the table. And again, the column name doesn't matter. It can take any number of parameters because later we'll bind this to the columns that we need. And here's that scalar result set. Now, what's this where clause? Well, the database principal ID function is going to be used here without a parameter to return the internal ID of the user executing the query. And it is going to be compared with the internal ID of either the username that is being passed in, that is in each row, okay? And this or short circuits the whole thing for the manager user. If the person running the query is the manager user, you're always going to return 1. It doesn't matter what's going to be in the column. I've got more code here without time to show you. This is Lenny's own special sauce that I added after that. This piece here, testing the predicate function, where you can see I kind of test it by trying to call it. You can play with that on your own. It's not necessary. You never call this function yourself. SQL Server is going to call this function. And so the next actual required step after creating that function is to create the security predicate. I'm sorry. We just created the security predicate. To create the security policy, which binds the predicate to the tables. And in this table, there is a column called sales username that is going to be bound to the one and only parameter. But if you have multiple columns that you need to kind of combine together to infer who owns the row, I mean, whatever is it's up to your application, well, then that's going to be just fine. You can map them as needed. And you can create the policy without turning it on and turn it on with a separate alter statement. But here I'll create it and turn it on in one go by adding with state equal on. We query from the table. And now we can maybe have a moment of panic. Is sales a view? Maybe sales is a view with a where clause that's hiding the data. I know there's 6 rows in this table, or perhaps 6 million rows in this table. Well, let's do a select count. And now we really start getting hot under the collar because we know this is a table and we're doing a select count and there's no data. And I'm DBO, right? In DDM, with DDM, you know, I had unmasked permission. Here I am in RLS world and I can't see anything and I'm panicking because I'm the DBO and there's no data in this table. Well, in fact, if there would be at least one row in that table with DBO in that sales username column, it would show up here, right? But we only have 6 rows. 3 belong to sales user 1, 3 belongs to sales user 2. The rows that come back are going to only be the rows that match. So it's, you know, starting to make sense. We'll impersonate sales user 1, query from that table. At least there's 3 rows of data, and if a select count indicates 3, and of course, reverting back to DBO, and now impersonating sales user 2. I again see 3 rows of data, but of course these are the other 3 rows belonging only to myself. So now you see how it works. And this is a real simple example. It's contrived. I realize, of course, that you're not going to have the string name of the user necessarily, right? It could be a GUID. It could be an integer ID. And also it could be everybody being the same as well in an n-tier application. Plus, we haven't talked about writing. Yes, sir. What about performance? The inevitable question. This is a cross join. It will perform as well or as poorly as your predicate function. So if your predicate function, like I said, if it's an ID that you get, and the only way to match the user in the row with the user name coming in as a parameter is to join on another table, and you join on a table that isn't indexed, you're going to hurt performance. But it performs like a join. And we all know what happens if you join on a column that isn't indexed. So that's basically it. Most of these features perform as good as, if not better than, anything you or I might roll ourselves. That's also true. And they're constantly improving the performance of these things. So, of course, if I impersonate the manager now, I get to see all 6 rows by the nature of the way we wrote the predicate function. Looking here now, impersonating sales user 1, I can't insert, I can't update, I can't delete, because again, we blocked all of those activities using traditional SQL Server permissions. So you know what I'm going to do now? We're going to clean up, and I'm going to show you another demo that gets a little more real. Yes, I have to revert first, and then I can just clean up here. All right. Right. Now, that was a little simplistic. In n-tier scenarios, you don't define individual database users, right? the users are authenticated individually at the application level, and that's fine, and the application knows who's who. But when it comes time to talking to the database, there's one connection string with one username and password or one service account that everybody shares, right? So the database principal ID function that we showed in the last demo is useless because it's going to return the same value for everybody. So that's one simplistic aspect of the previous scenario. And the other was, of course, that we're only filtering on selects, right? What about updates? Well, let's go ahead. I mean, first of all, you can mix this up in any way. Imagine a hospital scenario. You may want to allow a nurse to see only the patients on their ward and update only the patients on their ward. Or you might want to allow a nurse to see all the patients in the entire hospital, but only update patients on their ward. And you can mix these up by also combining filter predicates, which we saw in the last demo, with block predicates, which we'll look at in this demo. And we'll also address the N-tier concern with how do we know who is who if database principal ID is the same for everybody. So the scenario is actually the same. I'm going to create the same sales table as before. And I'm going to populate it with the same 6 users as before. But pardon me. However, I'm only going to create one user. Everybody's connecting as app user. So we won't be able to know who is who, sales user 1 and sales user 2 or the manager. And of course, app user will need access. And as before, we'll follow our best practice of creating a security schema and using that to store our predicate function, which I'll create first and explain second. Now, first of all, database principal ID is going to be the same for everyone in our application. So there's multiple levels of security here, right? Because if you're not in our ecosystem of users, then you won't even be app user. So yes, you won't be within our ecosystem of users for our application. I won't be able to know who is who, but at least I will be able to know whether you are in the group or not by whether or not the database principal ID matches. Because if you're not in the group, then you will not match app user on database principal ID. But then if you are within the group, who are you? Same logic as before. If the user is running the query matches the parameter being passed in, or the user running the query is the manager user, that's the same. But what's different is how we're identifying the user. And this is a segue, actually, into a fourth new SQL Server feature that I didn't promise I would show you, but I'll show you anyway, called session context. And you should only use it when you need to, and this is one of the best use cases for it. Session context is a stateful dictionary. It lives in RAM. It does not persist on disk. It doesn't get stored in a table, but it just lives for the lifetime of the connection. And so the application, after it connects, but before it issues its query requests or store procedure calls, can shove into session context in a read-only manner so that it can't be tampered with, so that you can pluck it out. And the extra convert and the Unicode there syntax, this just happens to be required because session context is a dictionary keyed by Unicode string whose value is an SQL variant type, which can be any type. And so you'll convert it to the type that you need it, which is a varchar in our case. That's it. Did I create that? Thank you. Not that I didn't trust you. That's just my own manic disorder. Skip this stuff that you don't really need to do and create the security policy like we did the last time. But this time I've added 2 block predicates. Notice after insert and after update. Now there's also before update and before delete. If you don't have a filter predicate, then you might want to use those 2, because if you have a filter predicate, well then it doesn't just block selects. It also blocks any records that might be returned for an update or a delete operation. So if there's a filter predicate, there's never going to be a chance for you to update or delete a row that you shouldn't be allowed to. But if you want, like the scenario I gave before in the hospital where you can see all the nurses' data, well, then you might also include a before update and before delete predicate as well. But here you see I'm using the same predicate for all. And now I'm going to impersonate that user. That is everybody. That's not going to be enough. This is the store procedure that the client application needs to call each time, storing into that key, using that key into session context, that value, which in this case assumed that I was authenticated as sales user 1. And now the demos work like just they did the last time. Right? I can see these 3
If I impersonate sales user 2, well, then I can see those 3. But now, because of our filter predicates, we can, I'm sorry, our block predicates, which we didn't have in our previous demo, we can also insert a new row for myself, sales user 2. I can add a new row for me, and now I've got 4. But I can't give my buddy work. I can't add a table for sales user 1. Only the manager can do that. I can't transfer any of my rows over to my buddy because, again, there is a block predicate. The message is quite explicit about the problem there. If I am the manager, of course, I can see all. And you'll notice this time I set read only equal 1, which is the way you must be sure to do in your application as well. So I really can't impersonate any further. So now the manager can insert a new row for either of them, sales user 1, sales user 2, of course. Can transfer, can do that transfer, okay, of order number 5. I'm going to give it from sales user 2 to back to sales user 1. And now the table looks quite different than it did before because of the changes made by the manager. If I try now to go ahead and impersonate, again, using SP set session context, it will fail. Why? It has been set as read only for this session, is what it says. And in fact, for those of you wondering, because I know I wondered and I got a lot of questions about it, in terms of connection pooling, when you close a connection, right, the connection isn't truly torn down because that's very expensive. And bringing it back up again, a fresh one, is also quite expensive. So there's a connection pool. Logically, it's closed. Physically, it's open. Session context gets cleared, gets flushed at that point. So you don't have to be concerned that you get a connection out of the pool with somebody else's context. That wouldn't work too well now, would it? All right, let me go ahead and clean up and ask if there are any questions on RLS before I jump into the third security-related topic, always encrypted. And in looking at the time, like I said, one of the ways I'm managing turning 75 minutes into 45 minutes is choosing between demos and slides. For our third topic, always encrypted, I'm going to resort to the slides. I've got a workflow slide here that explains everything. Let me just flip on up to, we might actually have time for some review slides on what we just saw. So let's look at those. We talked about RLS, how you need to create an inline TVF, and then you can write your custom logic to give access, and then you bind the function to tables using predicates by creating a security policy, the different types of predicates, the different ways you can mix and match these. Of course, the most restrictive case being combining all 3 like we just saw, but you don't have to. These 2 in case you don't also have a filter predicate. Just, all about how to create then a predicate function. Here's an example of the syntax. There's your inline TVF syntax right there. How to create the policy, what it means, and again, the syntax for review. All right. We also saw how in cases when you can't use database principal ID, typically for n-tier applications, how you can combine RLS with session context to make it work. All right? Yes, sir. So the question is about backup and restore. Yeah, these are schema objects that I didn't, there's limited time. I didn't show it, but in SSMS, in the tree view on the left, you'll see security policies. You can drill down. You can see these things, and they are first-class database objects. So you back up, you restore, certainly. Now, in the next demo, when we're talking about always encrypted, backing up and restoring a database is not the same as backing up. Is not the same as like moving the database from one place to another. The certificate does not travel with the database. So that's what we're talking about in our third and final topic in the what appears to be 12 minutes, which is perfect to get a good understanding of always encrypted. So first of all, are you folks familiar at all with the traditional SQL Server encryption features, notably encrypt by cert, decrypt by cert, encrypt by key, decrypt by key? Good, a few at least. I mean, somehow at least you're securing, you're encrypting your or protecting your users' passwords and social security numbers and the like, okay, one way or another. And one way that you can do it is, of course, using these column level encryption techniques that have been around for a while. But if you've been doing this as long as I have, and looking around, I don't think many of you have been doing this as long as I have, but back in the day before there were any database encryption features, how did you do it? You did it on the client, right? I mean, if I wanted to encrypt a password before I stored it in my DBase 3 database or FoxPro database. Is anyone with me on FoxPro? No, not one or two hands. Great. Well, how did we do it? We encrypted it on the client, stored it in the database, encrypted. The database would happily accept it. Garbage in, garbage out, right? And then you pull it out and you decrypt it again and compare, right? Well, in some ways, the more things change, the more they stay the same, because that is exactly the concept here. The modern twist, the modern edge, is the fact that it all happens transparently. You don't have to do any work like you did then. But the concept is the same. You store encrypted data in the database. Because the problem with encrypt by cert and decrypt by cert is that, well, first of all, the certificates themselves and the keys themselves that are needed to encrypt and decrypt data are part of the database, are first-class database objects. So the question about, like security policies also are first-class citizens. So that's fine when I'm hosting my database in my basement or my own data center, but one of the biggest obstacles blocking people from moving their data to the cloud is they have encrypted data, and they want a separation of those who own the data themselves from those who manage it, some cloud provider. And this becomes now a problem because I don't want to hand over my keys to my cloud provider. Furthermore, data is only encrypted at rest, not in flight. So yes, of course, one would hope that you're using SSL to encrypt a user's sensitive data when it travels from the browser to the web server. But what about from the web server to the database server before it gets encrypted at rest? It's decrypted in flight. And people don't only move their databases to the cloud nowadays, they move their entire networks. There are virtual networks running in the cloud, and now people hacking that wire will be able to see my sensitive data. So these are all problems with the traditional approaches. So always encrypted solves this. It's based on keys that are managed outside the database. There's a separation from those who own the data to those who manage it. SQL Server itself is powerless to decrypt the data. Right? This does mean you are burdened with client-side certificate management. But if you're still looking for something for free, the easy way around that is Azure Key Vault, as I'll talk about in a moment. There are two types of encryption. Randomized is the preferred encryption, but if you absolutely need to query on the data that you are encrypting, you will have to use deterministic encryption, and then that will give you limited querying. That will be case sensitive because it's binary now. Equality only because it's a what do you call it? It's a ciphertext value, right? So you can't do a range search on it. Greater than, less than, betweens won't work. But you can search for equality. You can't even search for inequality, only equality. So every column that you want to encrypt gets encrypted by a column encryption key. It doesn't, which is a CEK. It doesn't mean you need to create one CEK for each column necessarily. That's up to you. If you have 10 columns you need to encrypt, you can create 10 CEKs, one for each. You can create one CEK and use them for all 10, or you can create two and use them for 5. However, whatever makes sense. That really isn't what matters. What matters is the CMK. There's only one CMK, the column master key. And this is the one that only lives outside the database on the client side. Here's the workflow. So there is a wizard for this, and most of us don't like wizards. I know. We want to do it ourselves. We want to understand the syntax. We want to build our scripts. We don't want to use the wizards. But in the case of, and you can definitely do a lot of this yourself. You can create the certificates yourself. You can do all this in T-SQL. But the reason in this case why it's good to use the wizard is especially if you already have a table with data that's not encrypted and you want to migrate that data, the wizard will also kick off a migration process. So it'll do all the things you need to do to get started, plus it will also migrate an existing table. So let's say you have an existing table, like this one here. Very simple table. I've got a name column and a social column, both of which I'd like to encrypt. So we fire up a client, and the dotted line there is the separation between the client and the server, and the client in this case is the SSMS wizard that I just started talking about. And then we'll go ahead and create that column encryption key. I could create 2 because I'm encrypting 2 columns, but I'll just create 1 because I can do that too. And I'll encrypt both of these columns with this one CEK. And the SSMS wizard will also create that column master key, that CMK.
And it will store it away in a client-side location, which could either be actually more than these two locations are supported, but the wizard only supports these two. It could either be the client certificate store, but then you have, and now you've got one, but now you've got to distribute it to everybody else. Or it could be to Azure Key Vault, which is, I don't know, it's a little bizarre. People are so terrified of the cloud because of security, they'll then store all their precious keys in the cloud, you know. It's like, what? Because it is tempting not to have to distribute a great many number of client certificates otherwise. But in any case, it's only accessible to the client. And what goes to SQL Server? The CEKs, but not the CEKs themselves, of course, because that would defeat everything I just said. An encrypted version of the CEK, encrypted by the CMK. What about the CMK? Of course, the CMK itself is also not stored in the database, but client-side path information. This is the part that this is the modern twist. So ultimately, everything's going to happen the old-fashioned way. Encryption is going to happen client-side. But because of all of this kind of orchestration going on here, it's going to be just transparent. So the server knows how to tell the client where to go and find the CMK. And then the wizard goes ahead and kicks off the encryption process. And the gear is very deliberately there on the left side of the bar. Right? This is happening client-side. SSMS is using the CEK to encrypt columns. It's writing to a new table. When it's done, row by row, it drops the old table. And when it's done, it replaces the data, or the data is replaced with ciphertext, as it's called, this encrypted representation of the data. And when it's done, it goes away. And this is what you're left with. A database completely incapable, completely incapable of decrypting itself. It is simply powerless. If somebody has this database, they cannot make heads or tails of this data. Because to decrypt these columns, you need the CEK. And all you have are encrypted versions of the CEK. So there's double layer of encryption. The columns are encrypted by the CEK, but the CEK is encrypted by the CMK, and the CMK is nowhere to be found. Only client-side metadata about the CMK is present in the SQL Server database. Now your client comes along, your app, and it issues a query like this. It wants to get that name column, which is encrypted, and it wants a query on another column, SSN, which is also encrypted. Well, what normally happens is that gets sent to ADO.NET, and that's the client in this case. That gets sent to ADO.NET, which would normally ship it over the wire just the way you see it, but because you have now included column encryption setting equal enabled, okay, that's the one thing you have to do. Right? That's the only thing you have to do. You don't do that, it won't work, pardon me. You do that, and what happens now is this whole orchestration continues where the encrypted CEKs get passed to the client. The metadata about where the client can find the CMK is passed to the client, so the client can then go and fetch it from, let's say, either Azure Key Vault or their local certificate store. And there are other supported choices, not by the wizard, but there's also hardware security modules. You can actually have physical devices that you have to be plugged in, and then you have access to the data. And once it has the CMK, the client, can decrypt the CEK, and it can use it to send the query over the wire this way. Now, anyone hacking the wire at this point, that's what they see, right? And the only way this can work, of course, is if we're using deterministic encryption on the SSN column, because that social will always encrypt to that ciphertext each and every time. It's not going to work very well with like gender columns. It's not going to take a hacker very long to figure out that that means male and that means female if you're using deterministic encryption. So you only use deterministic if you need to query on it. SQL Server, yeah, fine, I'll find the result. Yeah, it's the result. I can't make heads or tails of it, but I'll just pass it back over the wire. Anyone hacking the wire in this direction, that's also all that they see. Yeah? So always encrypted means never encrypted anywhere other than, never decrypted anywhere else other than the client. That's what always encrypted means. Always in flight, always at rest, always everywhere except on the client. That's it. I think this is I mean, it works. I have the demo code that is attached to the zip file for my session. Has fully working demos. I hope you'll join me tomorrow for more new SQL Server goodness with JSON integration. And sure, I've got 2 questions left to take questions, sure. Great question. Well, I believe, the question was about Express. One of the nicest things that Microsoft did shortly after releasing 2016 was taking many of these features that were only available in Enterprise, and they pulled them down to standard. I think that means they're also in Express.
but that was really because there's also temporal. There's so many other good things we could talk about that they added to SQL Server that were available only in enterprise and like, I don't know, within 3 or 4 months after the release, they just made it available standard, which is really good. It's really great. Anything else? Yes, ma'am. Is this available in Azure SQL database? That's a good question. I mean, I would shoot from the hip and say yes, but I would double check that. I mean, it would seem to make sense. It's like it's consistent with the idea of separating those who own the data from those who manage it. So if I want to move my database to the cloud, am I talking about moving an Azure VM hosting SQL Server that has this feature to the cloud, or am I talking about full platform as a Surface SQL database, right? That's a great question. I really should know the answer to that one, and I'll get you an answer. I'm sorry? DDM and RLS both debuted on SQL Azure. Yeah, but I don't know about always encrypted. Thank you, everyone. Have a great day, and I hope to see you again tomorrow. Enjoy.